Good evening. Welcome to HydroniX Talk. This is a presentation of the Radiant Professionals Alliance. I am your host, Mark Etherton. A little bit of information on me. I'm the current director of the Radiant Professionals Alliance. I've been a member of this organization for the last 20 years. I'm a contributing editor to Contractor Magazine and have been for about the last 15 years. I've been an educator for 39 years. I'm a former expert witness and still a current licensed master plumber, but I don't share that information with too many people because they ask me to come over and fix their plumbing. I'll go over some quick rules of the road here. If you would please use headphones and boom mics if possible to avoid feedback and loopback. If you have a question that you need to ask us during the presentation, enter it into the typing Q&A box, and I will try to stop Ron and have him address your question immediately. Generally, some people like for us to wait until after the presentation is done, but Ron has agreed to take them as they come. I'd like to thank everybody for taking time out of their busy schedule to attend. Here's an example of some of the alternative radiant heating systems that I've been promoting during my tenure as a contractor. This is a radiant wall that we did for the Habitat for Humanity house. It was done about 20 years ago and still working quite well. Here's the ceiling of my home up in the mountains. That's a radiant ceiling system. It's connected to solar thermal, ground source heat pump, woody biomass. I've got just about every source of energy connected to this thing that's known to mankind. And this is the only commercial that you will see during this presentation. We would love for you to join the Radiant Professionals Alliance. Go to radiantpros.org and click on Join, and we can get you hooked up with a membership real quick. This is a volunteer organization of the members, by the members, for the members, with all the members as a whole benefiting from the actions, and the industry in general is our customers. Give you a little information about the talk show. This is a once-a-month affair. We have a guest interviewed. We have open question and answer sessions following the interview that can either be pertaining to the actual interview or not. We've got a special question we want to ask. Probably not going to find very many experts that would be assembled in one spot at one time that would be able to give it a shot. So if you have a question that's not related to what we're doing, feel free to ask it. These programs are archived for members only for review at a later date. You'd have to go to the Radiant Professionals Alliance website and click on Members Only, and then scroll down to the bottom where we have all of these programs that are archived. These shows are meant to be fun, educational, entertaining, and oh, did I mention fun? If you would like to submit a guest interviewee, please send them to me at mark.etherton@radiantpros.org. They do not have to be a member of this organization in order to be on here. We will give our members priority over non-members, but if you've got somebody that's got an interesting product or an interesting way of doing things, by all means, submit their name to me and I will interview them, and if they meet our minimum criteria, we'll be able to get them on board. Go through some quick hydronic news that you can use. The Radiant Professional Alliance's spring courses are available at heatspring.com. We have Dave Yates up there teaching. We also have Ray Wolfarth, as well as myself, and Vaughn Woodruff. And we are always looking for additional instructors to come in there and help us present some more topics. So if you know someone that would be interested in teaching, have them contact me and we'll get them set up. The AHRRPA Annual Education and Business Meeting will be occurring next week, January 25th, 26th, and 27th in Orlando, Florida. We're going to be celebrating Dan Holohan's retirement as well as his birthday party, and that will be at Tommy Bahamas, which is in Point Orlando, Florida. Reservations are required. If you would like to attend that function, you need to get a hold of Denise Voorhees at denise.voorhees@radiantpros.org and let her know how many people will be coming so that we can make sure that we reserve you a spot, food, and drink. Our partner, Tom Grandy and Associates, is putting together a program for our contractors called Planning for Profit. This program will be presented March 1st and 2nd out of our Mokina office in Illinois. If you are interested in this course, I would suggest that you contact either myself or Denise. for more information, and he's actually got a quick presentation that he's going to be providing the beginning of next month to give people a sample of what it is that he presents during this 2-day presentation. And after having spoken to numerous contractors who have attended this class, they've said that this is the best thing they've ever done for their business. The Canadian Institute of Plumbing and Heating and the Canadian Hydronics Council will be holding their annual conference in Toronto at the Metro Toronto Convention Center. For more information on that, which is March 16th, 17th, and 18th, you can contact them at cnpx@salshow.com. During our meeting that we're holding next week, we're going to have numerous classes that are being taught by volunteers on everything from how to do business, face plants. We've got a course that we're putting out about no sweat radiant cooling. It's one of the biggest areas of concern by most contractors is the potential production of condensation. I'll explain how it is that they avoid that. We also have a lot of different things going on. Come and visit us if you'd like at booth number 3659 if you happen to be in Orlando. Our membership meeting will be Tuesday from noon until 2 p.m. and we'll be holding a roundtable session during that to discuss numerous topics as well as your wishes, wants, and needs for this organization moving forward to make sure that we're fulfilling your needs as a contractor member. We're also going to be, as I noted before, we'll be celebrating Dan's retirement and his birthday, Tuesday from 6 p.m. until 8 p.m. And lo and behold, we're also going to be passing the Carlson Holohan Industry Award of Excellence to the next recipient. And if you want to know who that next recipient is, you're going to have to come to the show because it's a secret. The AHR show is the American version of ISH, except that it is in the United States. There are numerous European, primarily German and Bavarian contract manufacturers that will be present at this facility. If you've never been to one of these functions, you need to go at least once. This is an amazing show. There's a lot of people there with a lot of really good equipment, and it's a do not miss. Our member Cleffy is having Coffee with Cleffy tomorrow with Jody Samuel. If you're interested in attending that course on multiple temperature regulation and hydronic systems, it happens from noon until 1 p.m. Central Standard Time. And you need to go to the Cleffy website at www.cleffy.com to register for this presentation. The lawyers. The graphics and illustrations used in this webinar are presented for educational purposes only. RPAI APMO does not endorse or recommend the vendor, product depicted, nor any vendor or product. RPAI APMO makes no representations, warranties, or guarantees as to and assumes no responsibility for the products depicted, and the RPAI APMO expressly disclaims all liability for damages of any kind arising out of the use of or performance of the vendor's products or services depicted. There's our guest for today, Mr. Ron.
Yes, sir, I'm here.
I'm going to stop sharing my window real quick, turn it over to you for control, and let you take over here until the end, and then I'll take back over control again.
Okay, Mark, thank you.
Just a second, let me get my... You are the pilot, sir.
Okay, let me get into the web browser then. Gentlemen, I hope you can all hear me. As I go through here, if you have any questions, I'm happy to answer them as we go. And in fact, sometimes it's much better if we handle it that way. Mark, we're okay? You can see me now?
Yes, sir, I can.
Okay, our product is called ENV. And we really do believe it's the best of any control system out there on the market. And I'll try to convince you of that as we go through this presentation. If you don't know already, ENV is all about controlling all the HVAC and all the mechanical systems and curtains, if you want, and other types of things in the building. The first thing I'd like for you to do is to look at this video. We sell ENV through several different resellers under a private label. Ray Howe, if you know those guys, they sell it under Ray Howe Smart Control, RSC. There's several others that have a private brand. It's actually the same product with a different skin. But they put together a video that I thought is the best one that I've ever seen any of our resellers do. And I'd like to basically let you watch the video. And it's about 3.5, 4 minutes. And we'll come back to this presentation as soon as it's done. Mark, can you hear it? Mark, can you hear this?
HVAC systems are becoming very complex as more buildings begin using renewable energy. To get all this technology working together efficiently, your mechanical room needs a conductor that signals each system to power up or down at just the right time. It needs an intelligent building control system that maximizes your comfort and keeps energy costs as low as possible. Ray House Smart Controls brings harmony to energy performers with an easy-to-use computer-based control solution that is customized for you. Most buildings have individual controls for each HVAC system that don't talk to each other, so they can't be optimized. Ray House Smart Controls makes it simple. The computer communicates through a central control panel. All HVAC systems are connected to this panel through input-output blocks. Ray House Smart Controls optimizes energy consumption. It prioritizes energy consumption, using the greenest available energy sources first. For example, your home may be heated with energy from solar, geothermal, and a boiler. Ray House Smart Controls uses solar first because it's very efficient and free. Once the sun goes down and the stored energy is depleted, it moves to geothermal, which is the next most efficient source. And when the ground becomes too cold to support the demand, it finally turns on your boiler. Your contractor will configure the system to operate most efficiently based on information you provide about room use. During operation, you can review detailed performance data with your contractor and fine-tune the settings.
We were able to heat and cool the building without the use of fossil fuels, which is great from both a cost savings perspective and one of being as environmentally responsible as possible.
Ray House Smart Controls has access to weather forecasts, courtesy of the U.S. National Weather Service and Environment Canada. This allows adjustments to begin before the weather arrives. For instance, a predicted drop in temperature will prompt the radiant heating system to begin warming your floors to keep it consistently comfortable. Ray House Smart Controls is highly flexible and scalable. It's capable of controlling a few rooms with 2 types of mechanical equipment, or hundreds of zones with extremely complex HVAC configurations. After initial installation, any new HVAC equipment can be easily integrated.
Many controls just don't have the breadth and technical sophistication to understand how all the individual components should be operating at any given time. And because of this, there's often a lot of conflict and redundancy among them. The Ray House Smart Control System is the first I've ever seen that provides true system integration and optimization.
Ray House Smart Controls can be accessed from your smartphone or any other internet-enabled device. You can adjust temperature settings and on and off functions anytime, from anywhere, when connected to the internet. Your service contractor can also access your system and diagnose issues before arriving at your site. Ray House Smart Controls is designed for residential and light commercial applications. The greatest benefits are realized and achieved in complex systems. For example, homes with multiple heating and cooling sources, and light commercial buildings with a high density of people and many individually controlled zones. Would you like to take advantage of the latest technology and energy-efficient control solutions? Does your home need an energy conductor? Let us show you how Ray House Smart Controls can work for you. Contact us today for a design proposal.
Were you able to hear that, Mark?
Yeah, it came across great.
Okay, great. All right. People always ask me, well, why would I want to use ENV to control my project? And so we put up this chart as a kind of a litmus test that you might want to look at when analyzing that question. And let me just say up front that if you're talking about residential and it's just simply a forced air system, you don't want ENV. It just doesn't, it doesn't match. It's too much of an overkill. The primary criteria would, of course, be radiant, either radiant heating or radiant cooling. And the system can handle an unlimited number of anything you see on this chart: zones, sensor, outputs, inputs of any type. So we also do snow melt, and I'll come back and talk about that in a minute. So if you were looking at the system and you said, well, all I have is snow melt, our system scales. It would operate fine, a snow melt system. If you have a real complex sequence of operations, and we've seen all kinds, from a simple thing, turn on the boiler, to, well, I have radiant heating my water. I've got 25 heating zones. I've got 4 heat pumps, ground source heat pumps, etc. And I need for all that to work synchronously. I may even have domestic hot water that I want the heat pumps to heat, or even using the solar collector to heat the domestic hot water. And all that would be defined as a complex sequence of operation. 150 sensors is definitely a point at which you would want to look at an ENV. Sensors being temperature sensors, humidity sensors, flow sensors, BTU sensors, any type of sensor. We talked about solar collectors, multiple staged ground source heat pumps. I have several sites that are using more than one heat pump, each of which have multiple stages, heating a buffer tank that then is used to heat the floors. We also have one operation that is a large aged home for ill people. They have 150 rooms. They heat and cool. So they've got multiple heat pumps that are heating a hot tank and a cold tank simultaneously, which is really nice because it allows us to heat large public rooms at the same time cool other rooms and vice versa. Fan coils. A lot of our sites have fan coils for cooling and or heating, with including radiant, combinations of those two types of things, mixing valve strategies, zone valves, injection pumps. You can mix and match all these based on the design of the building. As I mentioned, buffer tanks for radiant and domestic hot water. We have one site that has exchangers that are not only used to heat the buffer tanks for the radiant floor, but also used through heat exchangers to heat the domestic hot water. Almost all the high-end residential, they don't want thermostats. I'm working on one project now. It's over 22 zones, no thermostats. And of course, that's going to save a lot of money. The the project I was just referring to that has 120 rooms, they have no thermostats. So the residents of each of those rooms, we have to keep those things comfortable. And we do that even without a thermostat. Simultaneous radiant heating and cooling, no problem, mixed in with forced air, either fan coils or systems blowing forced air. Heat recovery, ventilation, spas, wine cellars, and we can also interface to home automation systems. And I'll come back to that in a little bit. So if you look at these blocks and you say, well, 4 of those really make sense, then ENV is a possible use. Now, we talk about simplicity. I use the word elegant simplicity because it's just that. If you go into a complex residence or building, and the old methods, of course, always had a lot of these controls on the walls, and you got wires going into that might control a reset point or a zone valve, and then you've got relays that are wired together in order to do some complex sequence of operations. All that goes away. And so the way it works is we build a cabinet based on the number of points and the type of points. We deliver this cabinet to you. You hang it on the wall. It comes with a computer. You don't see it on this sketch. You hang it on the wall. You connect power. You connect it right here to your intranet. You bring in all your field wires, and they plug into these various terminal strips. You build the sequence of operations. You plug that into our computer, and you're ready to go. You don't need all those complex boxes on the wall. So in order to do this, what we need from our customer is three things: a points list, name and type, bathroom slab sensor, not transistor, I'm sorry, a thermistor, type 2, type 3, etc. So those would be the points list. Sequence of operations, how does it all work? And then a mechanical schematic. From those three things, we can develop all the tables, or you can do it, either way. Okay, so let's go through some of the features and benefits, and I'm happy to pause here if I have any questions. Mark, I don't see the questions come in, so you're going to have to tell me if they're there.
Okay, go ahead.
Okay. All right, I want to take you through a series of feature and benefit slides. First of all, we think this is really important, that there's no proprietary programming. The points, the sequence of operations, everything is defined through our screens, through click and point tables. Now, why is all that important? Because you don't really need us, our company, or our programmers to make changes for you. So if the customer or the mechanical contractor or engineer decides they don't like the way these two pieces of hardware operate, then you can go in through a web browser and make those changes. You do not have to know how to program to make all that work. The end user, by the way, he can create things like macros or set up virtual thermostats or create data monitors. Now, let me pause there and say that almost everything I'm going to show you today primarily benefits the mechanical contractor. The homeowner typically will come in and only look at his virtual thermostat. That's probably all he's ever going to do. So he doesn't understand or even have to understand all these complex things that I'm showing you. However, at the end of the day, all of this benefits him just in terms of efficiency, comfort, and cost. Okay, so it's web-based. We have a smartphone app for anybody. Of course, the customer would just simply click on the app, and it would automatically bring him into his thermostat. And he would see his thermostat, and I'll show that to you in a little bit, and he can make his set point changes, change the mode, turn on fans, or whatever he wants to do. Again, it's clear that any smartphone, tablet, a web browser, either Microsoft Windows or Macs, any of those things can get in from any place in the world.
Yeah, speaking of from any place in the world, just so I could say I turned my house up in the mountains here in Colorado from clear over in Italy. Just so I could say I did.
Okay. Did you do it in Italian?
See? Everything goes to Italian over there. My watch was Italian. Everything was Italian. It's like, I don't know, I'm lost.
Okay. So to make it really easy for you, we have built a number of what we call virtual control devices. And just think of a control device as a box on the wall. So for an example, you'll typically see a thermostat. That's a virtual control device. And you'll see a set point controller. To us, that's another virtual control device. A multi-stage set of relays that are going to operate a series of heat pumps in some sequence or turn on hot water. Those are all pre-packaged virtual control devices. And so from a develop the database point of view, you just simply select the virtual control device and give it parameters. You know, where's the inputs, where are the outputs, what do you want to do, et cetera. And the logic is already built in. Right, okay. And by the way, that's one of the ways we eliminate having to do any custom programming. Snow melt. This is a relatively new feature in our system. We think there's nobody out there that can do some of the things that we're doing with snow melt. For an example, we are looking at the weather service, and we can predict, as to the extent that the weather service is correct, when it's going to snow, if it's going to snow. Now, it's an engineering fact that if you can preheat a slab ahead of the arrival of the snow, you will consume less energy than if you waited for the first snowflake to hit your sensor and then turn things on. And that's all about idling. And so the user or the mechanical contractor can set up these tables that allow them to set up intervals that we refer to as probability intervals. And so, for an example, if the probability of snow is, let's say, 20%, then I only want to idle to 25 degrees. If it's 50%, I want to bring that idle a little higher. And if it's 90%, I want to go full bore. Those are all parameters that you set in the system. Confidence intervals, in other words. We don't know of anybody else that's doing anything like that. Or you can just turn on idle if you care to. There is no limit to the number of zones that we can handle, and there's no limit to priorities for each zone. So you could have a set of 3 zones that are sidewalks into the hospital, another zone which is a remote parking lot, another zone which is a close-in parking lot, and you can give those all different priorities. And what the system is doing is it's looking at the supply and return temperature of all of the zones. And in so doing, we can tell whether or not the heat source, whatever it might be, is keeping up with the demand of all those zones. And, we simply do that through some linear programming analysis. We can see the slope of that's delta T. And if it's going in the correct direction, great. But if it's starting to teeter and go down vis-a-vis, we don't have enough heat energy, then we'll start dropping off the lowest priority zones. And we'll keep them off until that curve comes back up. And then we'll slowly bring them on one at a time in order to maintain, balance in the entire system.
So you essentially have the ability to be able to set up a 3-tiered control logic for every snow melt system. In other words, no potential demand. The system would be sleep. The slab could follow the ambient night sky radiation, whatever it's going to do.
Right.
And if you have a potential of snow coming, that you could put it into a standby mode, which would maintain it at whatever temperature you're calling for based on the potential of snow. And then once you actually sense snow, then you'd send it into the melt position.
Absolutely. Exactly.
Fantastic.
Absolutely. It has all the features that you would have in your good manual controllers, like the Tecmar controller. It has some nice features for idling, et cetera, limits of different types. All that's in there. Now, by the way, Mark called me one day and we got to talking about this snow melt feature. And he said, why couldn't you harvest the heat in the snow melt zones? And you got all these pipes out there and the sun is shining and there's no snow in sight. Why couldn't you harvest the heat of the water in those snow melt zones and pump it back in and use that for floors or for domestic hot water? We can do that. We can do that because we control all the pumps. So we think that's a fantastic feature, and I'm going to continue to work on that with Mark.
I think it's going to be great when we can prove that we can actually harvest more energy off of snow melt systems than the snow melt system normally consumes in the process of melting snow. It's going to make for a whole lot more snow melt sales for people.
Commissioning toolkit. Once all this database is built and you get all these parameters in there, of course, the next step is commissioning. And commissioning can be a very complex operations, as I'm sure many of you know. We can make it really simple, and I'm going to give you some examples of why we do that. We offer this toolkit. It's all part of the software. There's no hardware in that. We have this thing called the simulator, data monitors, and a visualizer. And between those three things, and you're going to start to see examples of those in a little bit, we can really speed up the commissioning. For an example, if you come back to this box, all the outputs connections have what's called a hand switch. And this is without our software running. You can put that output into a manual on mode and then just debug without our software running your physical wire connections and the operation of the device that you're trying to operate. So you might have a motor connected to a digital output. You switch it on, see if the motor goes on. If it doesn't, you have some kind of problem. That is a really nice feature that's just part of these I/O block devices. The other thing, and I'll come back to this in a little bit, is this thing called the simulator. So you can actually, once we've built the database, or you've built it, without anything attached to that box, you can simulate the sequence of operations in all your points manually. You bring up the simulator, you turn on the visualizer, which I'll come to in a minute, and you can actually change values. So let's say you have a room sensor or a thermostat. Through the simulator, you can actually force the temperature up to some number. If it's a thermostat, let's say the set point is 70, you bump it up to 75, you're going to start to see things turn on and operate. And by doing that, you can debug a lot of the table entries that may be a problem. Data mining, there is, again, virtually no limit to how many data monitors you can create. We have a massive SQL database into which all that information is stored in real time. You can tell us how long you want to keep the data. For each of these different data monitors, you can tell us the sampling rate. So for an example, if you're sampling room temperatures, there's probably no need to sample that more often than every 30 minutes, based on what you want to do with that data. If you're sampling a mixing valve, you may want to sample that every 5 seconds or 10 seconds and keep that data for several months, because you want to come back and see how well that particular device is working. So those are really nice. And then once that data is in there, with a couple of clicks, you can see it in a chart, and I'll show you that. You can see it on spreadsheets, and then save the spreadsheet if you want. You can see it on an animated graphical view, which we call the visualizer. And it's truly a graphic real-time view of actually what is going on at the time. There's also a thing we call the real-time monitor. It's when you just want to look and follow in real time what the value of one or more points. Virtual thermostats, I alluded to this earlier. You don't have to have physical thermostats to make this thing, hum. You can have slab sensors. You can have wall sensors, ambient temperature sensors buried in the sheetrock. You can have both wall sensors and slab sensors. You can have thermostats. We see some people wanting a physical thermostat in guest rooms so that, their guests can set their temperatures as required. When you have a slab sensor, and a ambient temperature, you get into a situation called MRT, mean radiant temperature. And as you guys all know, radiant sources feel better on your body than forced air sources. And there's a point at which, if you balance those two things, or you balance the ambient temperature against the slab temperature, you actually can increase comfort. And we let you do that. You can weight the temperature on the slab differently than the ambient temperature sensor. By combining those two weights and getting an MRT, we can use that basically to measure against a set point. And that works really, really well. We getting any questions, Mark? Do I need to stop?
No, you're doing a good job.
Okay. This feature's been in the system from day one, and we're always very proud of it as well. It's an interface to the NOAA or Environment Canada to get forecasts. We actually can go out 7 days, but all that's really important is probably the next 3 to 6 hours. Now, how do we use that? Well, as you guys know, you can get into a situation where you overcharge a slab because you've been operating at a temperature that's too high for too long based on the current real outdoor temperature, as opposed to what the reset curve might give you based on what it's doing. So what we do is say, look, we have a rapidly increasing outdoor temperature. It's 4 o'clock in the morning. The outdoor temperature is 20 degrees, but at 6 o'clock, that temperature is going to start rising 50 degrees, 40 degrees, whatever the rise is. You can use the mathematics of that increase to change the reset curve. And just think of it as taking your reset curve and sliding it up parallel to itself or sliding it down parallel to itself based on forecast. And that would allow you then to start keeping the temperature of the slab in line with the forecast, not with the current outdoor temperature, because it takes so long for that heat to disperse out of that slab. And the reverse is true too. It's late in the afternoon, it's starting to get cold. The outside temperature is affecting, right now, it's affecting the reset schedule, and you just don't get warm enough in time. This is a great energy saver because there's no need to keep pumping a lot of energy into a slab if, in fact, the temperature is going up.
I'm going to have to introduce you to my friend one of these days. I have a design for a night sky re-radiation sensor that essentially gives you the ability to be able to see when you're going to have sunshine.
We can do that already, Mark, by going to, there's some formulas that we use to compute sunset and sunrise and sunset. And we can use that in our system to do exactly what you're saying.
Yeah,
I don't know if that's what you mentioned.
You're going to be able to use if you're using NOAA, then you know that it's going to be a clear day, so you can start suppressing calls for heat or push down on a reset configuration based on the fact that you're going to have a lot of free sunshine coming into the windows soon.
Yeah, we haven't gone that far with it right now. We make that information available to the guy that's building the database. We haven't automated what you were talking about, but I think that's a great idea.
Mm-hmm.
Macros. The user will use these, and he'll set up his own as well. And what does a macro do? Well, a macro basically, you build it. They're easy to build. You can have as many as you want. And a macro basically is a way of changing the environment. You can change set points. You can change the mode. You can turn off a heat sequence. You can turn off a heat pump, or you can turn off your domestic hot water. Pardon me. So that's what macros allow you to do, and I'll show you some in a little bit. They can be executed in one of 3 ways: via a click by the user on his browser or smartphone. So I'm going on vacation. The computer doesn't know that, and I just simply bring up the macro on my smartphone and click on that specific macro, and it will go into whatever the rules are for that macro. Maybe that macro says turn these zones off, set back these 5 zones, etc. It can be very complex. You can also run macros on a predefined schedule, and they just run automatically. So for an example, and you set time zones for them. So for an example, here in my own home, I've got my domestic hot water shut off at about 9 p.m. That's done through a scheduled macro, and it comes back on I believe we got it at 6 a.m. It comes back on. I'm also scheduling through a macro my recirculation, my domestic hot water recirculation. As you know, recirculation, is just eating up energy like crazy, and there's no need to recirculate while everybody's asleep. So, and also there's no need to recirculate at the temperature of the domestic hot water tank, because most 90% of the time you're just going over to a fixture and washing your hands or rinsing off a dish. It's only when you're stepping into a shower that you really want a higher temperature. So I've got my recirc running at, I believe, at 105 degrees. So I always know, and I put my temperature sensor at the return point to the domestic hot water tank. I always know when I turn on a faucet that I'm going to get at least 105 degree water. Of course, that's a variable. You can set those wherever you want. The third way macros are executed are based on a true or false condition. So let's say you have a digital input that comes from your alarm box, or you have a temperature sensor in your mechanical room that's just measuring the ambient temperature in the room, or a temperature sensor on a pipe or something. Whatever it is, you can build a criteria of one or more of those things. And again, there's no limit. And if that criteria is true, we can execute a macro. So for an example, a good example would be that let's say you're heating with radiant, but you don't have any of the fan coils or your forced air running, because that's not the way your system is normally set up, and you go on vacation. And all of a sudden the radiant system goes down, a heat pump falls. Well, that macro would catch that, that condition would be caught, and you could, for an example, with the macro, turn on your forced air system and let it, start pumping out hot air. So no limit to how many you have, and the rules that the macros execute are basically unlimited. Alerts. There's no limit to how many alerts you can set up. And the alerts can be executed, caused to be executed, again, based on a condition. These are independent of macros. So again, for example, if you're measuring a temperature in a room or slab, or you're measuring water flows through a water flow meter, and something goes south on you, you can cause an alert to go out. And it's sent out as either a text message, you'll get it on your cell phone, and or an email message to everybody that you want to get those text or email messages. Typically, they go to the mechanical contractor and to the homeowner. But again, those are all parameters. Customer care. We run a server that is constantly monitoring all of our installations, including Ray Howe and our other resellers across North America via a handshake. And I'll tell you where this is really important. If you have, let's say, a remote location, like Mark has a wonderful place up in some mountain, if the power goes out up there, everything goes down, including our computer. So there's no way we can send an alert out. But our server knows that because the handshake stopped. And so we can send alerts from our server to that same list of people. And that's a really nice feature. That handshake is also looking for other types of things, like just communication failures or the backups. We run nightly backups. The backups failed. There's an excessive number of critical conditions, like internally we communicate with all these devices. If there's a lot of communication errors, those are also reportable from our server. We also notify you of new product releases through that same pipe. We've already talked really about domestic hot water. I just think this is a great feature. You can do this. There's no magic here with other types of controls. You can do the same thing for your return water, et cetera. You can do all those things easily enough, but we have all this integrated into one very nice system. So if your domestic hot water is being heated from a heat pump and you have enough capacity to heat the domestic hot water and your floors, we can figure that out. This is a lot smarter than having an independent control. deal with that kind of logic. So yeah, some of these things you'll say to yourself, well, hell, I can do that, but you can't integrate it to a complex sequence of operations without some kind of management system.
I got a question for you.
Sure.
This is from Harvey. He wants to know if the controls are available in different NEMA enclosures suitable for various environments.
The enclosures, I think you can specify. We don't make we don't build any hardware. We do not sell hardware. We use a third-party company that builds the cabinets. I don't know. I'm not familiar enough with NEMA, but I believe these cabinets are NEMA certified, and they have a locking door. You can close it up, and it's nicely built cabinet. Does that answer the question, Mark?
I think it does, and NEMA actually has a number of different standards that they have for NEMA enclosures. In other words, you could have one that would be in a wet application. I think that's a Type 3 outdoor wet potential. And okay. I'm pretty sure that the company that built those controls for you has that as an option.
I don't think you'd ever want this cabinet outdoors, though. This typically sits in a mechanical room, and you can have multiple of these cabinets. You can spread them out and put. I've seen some large houses with multiple mechanical rooms, so they'll put a cabinet in each one just to minimize the runs on the field wiring.
What's the name of that company that does that for you again, that builds those controls?
Well, Keeley has built them, but we're starting to use another company that we like a little better. They're actually here in Atlanta, and so we have a tighter control with them, and we're working. We can work more closely with them as need be. Whereas Keeley's over in Memphis. But
yeah, I've used Keeley before. That was a nice product. It came out really well.
Yeah. Either one, they're fine. Backnet. Some typically commercial sites want backnet. Although we're doing a residence right now that wants backnet. So we talk backnet, Modbus, or just pure ASCII over our communication bus. And that the mechanical contractor just says, well, I want everything backnet, or I want a combination of backnet, Modbus. We don't really care. You just set up the system through our tables, and off we go. Home automation interface. We see a lot of homeowners that they don't really want to go to their cell phone. They have Savant or Control4 or whatever. They just want to be able to just simply go to the Savant screen that they're familiar with and bring up our virtual thermostat. That's typically what they do. Savant has already got some of this stuff programmed, but we offer the methodology for any of these systems to have access to our database. They can they can set fields, they can read fields, they can do pretty much whatever they want through that home automation interface. Our team, one of the things that I'm most proud of is that we came into this project without any bias. We never sold hardware. We never sold HVAC equipment. My background is all software development. We've created a great number of critical applications for banks all over the world. And I built my own home in 2004 with radiant floors and forced air systems, heat and cool, and quite honestly, they screwed it up. And, I have an architectural home, and it just wasn't working right. So I said to a guy that was a mechanical contractor engineer, and I said, could we do something about this? And so he said, well, why don't we build a computer system? And that's how we got here. I brought in some programmers, and I did all the design work myself, and we started building this system. And we did some pretty simple things in the beginning. We got the basic underlying architecture right out of the box, again, because of my software background, and we began to add to it. So that's how this thing came to be, primarily because of my own need. And in fact, my own home is my I guess call it the alpha site for everything that we're doing.
Necessity is the mother of invention.
Yeah, exactly. Any questions about all that? I know I'm hitting you with a lot of stuff.
I have a question, personally.
Okay.
On your domestic hot water control, and I know Rich McGrath, who's also participating as an attendee, is very much into variable speed pumps, and there's some controversy within the industry as to which one's better, whether it would be based on differential in pressure or differential in temperature. But going back to your domestic hot water controller, for recirculation, is it possible to take a DC ECM circulator that has an input of 0 to 10 volts DC and use your control to vary the speed of the pump based on temperature differential? So as the temperature differential becomes real close, say 5 degrees between supply and return, then you turn the speed of the pump way down and maintain that 5-degree delta T. And if somebody starts using a lot of hot water and the delta T goes up, then you increase the speed to drop that delta T down?
Absolutely. No problem with anything you said. And, this sounds like a crazy claim, but there is no sequence of operations that we cannot do. Now, if you come into a situation that is more complex than any of our pre-packaged virtual controls, you could build your own virtual controls. You can. With several of the tables, you have to combine tables, et cetera, and you kind of daisy chain tables together, and you can create anything that you want.
Limited only by your imagination.
Absolutely. There was a vendor out there 3 or 4 years ago that built an HVAC DDC control system. And it was nice. It really was a nice system. But all the internal logic was they had to program it. And then, they set it into the customer site. And they had trouble, primarily not because of the original software that these installers wrote. It's when you have to come back and change something. We experience that in our own software development. We might develop a piece of code 4 years ago, and we want to make a change to it. This exists in the world of software development. When you go back into that source code and try to figure out what you did 4 years ago, it's really complicated. So you'll spend several days just refamiliarizing yourself with what you did 4 years ago. If I bring another programmer in to look at code written by somebody else 4 years ago, that's a fiasco. And they wind up rewriting everything. The new programmer comes in, he can't figure that out. So he rewrites it. And so this vendor I'm referring to, that was the approach they took. And it really killed them. It killed them because of the cost of trying to maintain their sites. Okay.
I have a question for you.
Sure.
Harvey wants to know if we have the ability to be able to overtake the operation of a proprietary ECM motor.
ECM motor. That's a variable speed motor, isn't it?
Yeah, it's like a DC electrically commutated motor.
Yeah. All these control devices we have, they can all be disabled. So you can actually turn that specific function or subsystem off by just clicking on the button that says disable. And then you're at the mercy of however you want to control that.
I know my experience with some of the inverter technology that's available for the larger pumps is they give you a 0 to 10 volt input signal to it to basically control that device. So we could use your small box to control a larger box to control a 100 horsepower pump.
Yeah. These blocks are not, there's no intelligence. And these are just A to D converters. So on the input side, which we call analog in, you can have 0 to 5, 0 to 10, 4 to 20 milliamps, or just dry contact as a digital, signal. On the output side, we have just dry contact for digital outs. You want to open or close a relay or send a signal to a heat pump, close a circuit, just like a thermostat. Those are called digital outs. And we also have analog outs. And we're using the analog outs are 0 to 5. I think it's the same thing, 0 to 5, 0 to 10, 4 to 20 milliamps. I may be wrong on the 0 to 5. It may be just 0 to 10. But whatever it is, we use that primarily for modulating devices like variable speed pumps that want a signal that, is parameterized based on a temperature, for an example, or based on something. We can then, vary the value of that analog output, which of course, varies. So if you've got anything controlled that is, PID, for an example, or what's the other one? I forgot what there's several of those kind of mathematical things. We support all of that. But I've seen some devices that you power open and spring return, or you want to just simply move it slightly open or slightly closed in a modulating fashion. We can do all that with an analog output.
PID, I think, is what you were thinking of.
Yeah, PID, but there's also one, another one we've used for wax-filled actuators where you want to just kind of keep bumping it.
Yeah, keep it warm.
Yeah, keep it warm, and that's, I apologize, I can't remember the term.
Anticipator.
Yeah, there's a mathematical formula we use for that second one. Okay, the toolkit. I mentioned this earlier. There's basically three things in the toolkit. The simulator, and you're looking at this on a screen. I can show it to you if we have time. And you can open up. Can you all read this, Mark? This is
it's a little tough to see.
Yeah, it's a little not clear on my screen either. By the way, you can come into our website and see everything I'm showing you now. But you can open up these various drop downs, tree views like analog inputs, and manually make a change. So if you have a temperature sensor, you can take that temperature sensor basically offline and manually change the value of that temperature sensor through the simulator, and then just see what that causes to have happen. So you can predict, let's say, or you would predict that if I change the temperature to 85 degrees, then these things ought to go on. This pump ought to go on. This heat pump ought to go on. This fan coil ought to go on, and you can then see that happening through our visualizer. So visualizer is an iconic representation of anything you want. First of all, you can everything you see here was done through the visualizer. There was no third-party design product. It was all done through our visualizer. However, if you want, you can create the background, all these lines, all these various things, using whatever tool you want to use, and then paste that background into our system. And then after you've done that, you can paste onto it these various icons that come out of our database, and you can connect these icons to any of the points, analog in, digital out, digital in, etc., and make those things animate based on those values. And I'm going to show you an example of that in a minute. So this is really versatile. Like you see these little arrows. If one of these zones comes on, this arrow represents a water flow. These are radiant zones. And so you'll start seeing that arrow moving back and forth. And then data charts. I mentioned that we've got this very powerful SQL database that allows you to store data for years or weeks or months, for as long as you like in terms of sampling rates, et cetera. And all you have to do is click on a screen, decide which fields you want to see, and you can bring up this chart. I mentioned earlier, you can also bring it into a spreadsheet by clicking and pointing, or pointing and clicking. No complex steps. So you look at multiple fields at the same time. I could look at a digital output as well as a temperature and plot those on the same graph to see how they're working in unison with each other. Here I'm looking at two separate temperatures. You can see they're tracking. I believe this example, I'm looking at the temperature at the top of a tank and at the bottom of the tank at the same time, and you can kind of see they're tracking. Right here, a pump probably went on and drives the temperature up, back up to the same spot as the top part of the tank. Different scale factors. Here the scale is 0 to 5. That's probably just a digital output on off kind of thing. And here we got temperature. There's 5 or 6 or 7 different scaling factors: flow rates, BTU, temperature, or just a pure value.
I have to tell you that data chart is one of the handiest darn tools I've ever seen before. You get a call from a customer that says, we didn't have any heat Sunday, but I didn't want to call you because I knew it would be expensive. You can go in with this system and go back to Sunday and pull up all the parameters of the system, see the supply and return lines, wherever you have sensors, and do a diagnosis on it and go, oh, yeah, here's the problem. Looks like it went for a trial for ignition and must have a bad hot surface igniter or whatever. But I've used this tool on my own house to be able to diagnose a situation where I was looking at the temperature of the house remotely. When I'm not there, I leave it set at 40 degrees, and the house was staying at 45 degrees. And I scratch my head, and I'm looking at the boiler supply and return, and the heat's not coming from the boiler. And I asked the wife, I said, did you remember to turn off the fireplace? We have an electric fireplace. And she went, uh-oh, no. So I knew then that the fireplace was keeping the house at 45 degrees. I couldn't do anything because it's an hour and a half away, but at least I knew that the reason my house is staying warm is because this device was left on or whatever. My next move is to put an interrupter relay on that fireplace, by the way.
Yeah. Mark, thank you for throwing that in, because I hadn't mentioned that. We see a lot of situations where the mechanical contractor can do exactly what you said. And in a lot of cases, he can diagnose over the telephone and, tell the homeowner, would you go look at the heat pump? Is it on? Oh, it's not on. Is your breaker tripped or something, et cetera? So there can be a communication over the phone without ever having to get into the truck and consuming hours coming and going, money that you would charge that homeowner. Also, we've seen situations where through that diagnostic, you probably can figure out what parts you need before you go. And that's also really nice because that eliminates then a return trip back to, your parts house.
We have a question for you.
Okay.
Rich wants to know if we can track gas and electric usage with these charts along with temperature and other condition points.
The answer on electric is yes. We have a device that we can buy through a third party that has one of those little donuts.
Transducer?
That clamp around the, any electrical wire. I have one on my heat pump. I also have one on the power coming into my house, and I can sample BTU, I can sample kilowatt hours, whatever's appropriate. I know of no device that samples gas.
I do.
If there is such a device, install it, tell us what the output looks like, and we'll sample it.
I can tell you that. I actually have a gas meter in my house here in Denver that has a pulse output. For every cubic foot, it gives you a pulse closure.
You can do it right now, Mark. You don't need any other device. You take those two wires and plug it into an analog port on one of those I/O blocks, and we can count those pulses, and we can scale it to your gallon, whatever you just said, per pulse.
Yeah, which we'd have to because our gas here in Denver is actually derated. It's not 1,050 BTUs like everybody else gets. Ours has been filled with air, so it's only 830. So we could take each one of those pulses and multiply it times 830, and that would tell us how many BTUs per hour the system's taking on.
Absolutely. No
Cool.
problem at all. Okay, snow melt. This is really two more things. The snow melt, we have a dashboard. This is, again, probably hard to see, but through this dashboard, for an example, you can see the forecast for the next 6 days, whether it's going to snow or not. Over here, you can select any one of the virtual devices. So here are all your zones, what it's doing, the status, the temperatures, etc. Here you have various controls like your boiler, what stage they're in. Here we have a zone group. You can have groups of zones and measure the supply and return to those groups. You configure all these through our software. Let's see, what else have you got? By the way, you can have several different mixing strategies. Typical home isn't going to have this, but if you got in a commercial, like for an example, we're doing the Denver, what's the name of their football team, Mark? Denver Broncos, right? We're heating their practice fields with ENV. Those practice fields get really cold. So we're managing the temperature of the soil through ENV. We have, whatever detectors they're using to measure that coming back into our system. We're sending hot water out there through pipes, and, it keeps the grass happy and it keeps the players happy. So,
I'll bet the players are real happy.
Yeah. I'm not sure if they're doing it on the stadium or not, but they're definitely doing it on the practice fields.
They do it on the stadium too.
Right. So if you get into a large snowmelt operation, again, we can handle unlimited number of zones. You may have different mixing strategies. So you might have a set of zones that are on a mixing valve, open, close, whatever, tracking kind of thing. Pulse width modulation. That was the term I was looking for. So you might have a mixing valve working on that application. You might have an injection pump working on PID, and you may have just a straight through zones where you're pushing water through it directly out of your source devices. Your heat devices. Any or all of those, or combinations of all of those. Again, I'm talking about installations that have got a lot of zones. So anyway, this is kind of a dashboard, and you can click into these various things and see, drill down to specific things. And across the bottom here, we run kind of a manic, what's it called? A marquee. And this, you can tell us which fields you want to see on this marquee, and they just keep rotating through, which is really nice because there may be like, here, this is the forecast, chance of precipitation. You could put outdoor air temperature, and any number of fields that will cross through that marquee.
I see a famous name there you're scrolling up on. Is Dr. Kilka still with you?
Yeah, he's an advisor. He's an advisor to me, and in terms of helping me understand the engineering. He was very involved in the original design. He told me some things that I still don't understand.
Yeah, he's a pioneer.
Really don't. Yeah, he really is. And he's the one that educated me on the fact that you need to preheat the slab ahead of the snowfall.
Yeah, proactive is much better than reactive in any situation.
And as soon as he said that to me, then I realized we need to use the snow forecast to do that. So that's the kind of stuff he helps me with. Yeah, this talks about that. Virtual thermostats. If you're on a cell phone or a smartphone, what you see basically is this blue thing. And you'd see across the top here, these are the various zone groups. So let's say you have 200 zones. That's crazy. Let's say you have 20 zones. 10 of them are radiant, 5 of them are forced air, 3 of them are fan coils, et cetera, et cetera. You can put those together into groups. So I've grouped all my radiant under a tab called radiant, obviously. I've grouped them under the other ones under forced air, et cetera. You can also just put them all into a thing called all zones. And you can just, this is the way it would look on your cell phone. You just click on whichever group you want. And so what comes up here then is this view that you see right there. And then there'll be a drop down right here that will show you all the zones within that group, and you select them. Now, this is a tablet view or a browser view, either way, whichever you want to be on. And this is much nicer, much cleaner because you have more real estate. And so you select the group, and then over here, you select which of the zones in that group. And it scrolls into that particular thing, and you can set up the set point with these 2 buttons. You can turn on the fan. You can change the mode from heat to cool to automatic, etc. You can click this and see all your macros and click directly on your macros from this, or you can switch back into what we call the dashboard, which I'll show you just in a minute. Yeah, this is that healthcare facility, 120 rooms and public spaces without a single thermostat. No problem for us. Can you imagine how much money we save them just on thermostats? These thermostats run, $100, $120, $200. Some of the nicer ones that people want times 120. I don't know what that number is. What's that, $4,000? No, it's more than that, isn't it? Anyway, they saved all that money by just simply putting in wall sensors. Okay, that's the end of this part of the presentation. Are there any questions?
There were, but I answered them.
Okay.
Rich had a question. He wanted to know if it had the ability to be able to do both through the computer. In other words, he has some customers that are paranoid about people being able to get into their secure systems and wanted to know if this could operate as a standalone system. And I explained that it could, but that he'd lose a lot of the functions like heartbeat and the ability to be able to send out alarms and the ability to be able to go in and adjust parameters, but it could be done that way. Then his next question was, would it have the ability to be able to do both through the computer? And my response is that basically, if you had the modem disconnected and the customer had a problem and wanted you to look at it, they'd have to plug the modem back in again, but they'd also have to have a static IP, because if they had one of those IPs that changes all the time, that you wouldn't be able to pick it up and figure out where it was at.
Right. Let me clarify a little bit for you, Mark, if you don't mind.
Sure.
First of all, we don't care if you have a static IP or not, because our heartbeat picks up your current IP every time you get that pulse every 5 minutes. So if the IP changes, when you go to your cell phone and try to get to your home, you're in Italy, you're really going through our server, and our server redirects you to your home computer. You have to be, your router in that building has to be on the internet, or you cannot do that. And of course, just as you said, Mark, the heartbeat quits working. Now, if you want to disconnect us from the internet, that's no problem. We don't really use our server to run the building. It's all done with the on-site computer. I mean, it has to be done that way. If you try to operate a home from a remote server and that connection goes down, you may have a heat pump running away. Yeah. So everything is done locally. And if you do it locally, the homeowner can still get to that computer through his cell phone. He just presses a different button, or his browser, etc. There's a different way he gets in. We set those up for him on his browser, and he's still in full control. Everything's still going to work the way it does if he has his router set up. And you don't really have to unplug it. You can go to the router and block a port, is what it's called. And you block that port, and nobody can get in with that port blocked. Does that answer it?
It answers it to me. I don't see Richard asking any additional questions. I'm sure he's going to be calling you and asking you.
Happy. No problem. If you go to our website, there's a number of articles. In fact, Mark wrote one of these. This one here, Adventures in Hydronics. Hydronica. That you might want to read. So here, I'm not going to go through this unless you want to, Mark.
No, that's fine. They know where this information's at. They're all members of contractors.
Yeah.
You did some work with Missoula State up in Montana?
Yeah, it wasn't Missoula. It was...
whoever it was up in Missoula, wasn't it?
Yeah, no, it was... I'm sorry, it was done through Ray Howe, so I don't remember it. It was a major test site. Ray Howe put every piece of equipment that they manufacture and connected it all up with different kinds of devices, and they've been monitoring it for 2 years to see what combinations of equipment really make the most sense. And that was done through the university. I think it was University of Missouri. What's the other large city up there? Bozeman. In Bozeman. Yeah, Bozeman. And so that was a great site for us to kind of see what was going on. What else have I got? Oh, brochure. You can download this brochure if you want. From our website, it shows you a typical home. It's got some more. This was something Beryl gave me. It has to do with that mean radiant temperature.
Yeah,
And
operative.
operative temperature. That was the thing I was trying to think of. And apparently they did a bunch of studies and they found out that if you operate in this zone based on humidity and temperature, you'll get more productivity from workers and more comfort. And so I mentioned earlier, we can program to that. We don't have an operative temperature sensor because it isn't one that we're familiar with. We just balance the slab against the ambient and kind of get close. By the way, huh?
That's what operative is. It's basically the surface temperature of the floor and the air temperature.
Yeah, exactly. So you can balance those in managing whatever you want to manage. You can average them, you can weigh them, et cetera. We also, by the way, can handle humidity sensors because in a radiant cool situation, as you guys know, you don't want to have moisture accumulating on the floor or in the piping. So we can manage to a what's the word I'm looking for, Mark?
Dew point sensor.
Dew point sensor, right? Exactly. And we take a humidity sensor and the temperature in the room. We calculate dew point, and then we make sure it stays above that dew point. Make sense?
It does, and it's absolutely critical if you're going to get into radiant cooling that you do that. Otherwise, you'll find yourself bound up in court over a black mold lawsuit.
Yeah, absolutely. And, of course, the other thing for radiant cooling, you don't want to get the slab too cold, notwithstanding humidity, because you can, hurt people that way too. So we obviously can manage the temperature sensors. We need a slab sensor in that case.
Mm-hmm.
If you want to reach me, just go to my website, key in your message and submit it, and we're ready to go.
Did you want to take them in and show them your visual graphic a little bit closer?
Yeah, I sure can. Let's see.
Your visualizer?
Okay. Yeah, I'm actually going now into my own site, my own home. And I don't want to scare you with all these screens because, again, the homeowner is really never in all these screens. He can be if he wants. He can be, but typically he's not. So from here, he can go in and execute his macros. He can come to his control devices. Like one of these 23 pre-packaged. So this is managing the domestic hot water. And so I'm using a heat pump. Right now I had some guests, so I can only get so high on my heat pump. So we had a house full of guests this weekend, so I turned on the electrical unit for this. But you can change your set point right here for that particular thing, whatever, mixing valve, whatever the various things are. Now back to the Radiant. If you want to actually see that virtual control device, you click there, and you see that screen I was talking about earlier. There is let me take this up a little bit. There's that marquee I was telling you about. And again, you can program what that marquee is showing. So I have some outstanding alerts. I see all my forecast temperatures from now through whatever. That's humidity and humidity, high and low temperatures. I now want to look at my forced air zones, or I want to look at all zones, or I want to look at my main living area or my bedrooms. So again, a zone can belong to more than one of these groups. So when I get into a zone, I can change the mode. Right now, my theater radiant is off. Now I'm in heat mode. Basically, this is no surprise. This isn't rocket science. I really only wanted you to see the usability and how easy it is to make changes from this. This is called the strategy. And I mentioned to you about overshoot and undershoot to the outdoor reset calculation. You can also set up that same kind of logic in your zones. So you can adjust. Let's say you have a poorly designed zone. It pre-existed and you're coming in there trying to fix things up. You can then adjust the set point automatically based on forecast in that zone. You can adjust it up, down. You can apply it to all your zones. You can turn that zone into continuous circulation, et cetera, et cetera, et cetera.
Well, it's only 38 degrees outside, 39?
Yeah, not bad, right?
You're in Atlanta, right?
I'm not in Denver.
No kidding. I'm headed for Orlando. I hope it's warm there when I get there Saturday.
Okay, data charts. This is just showing you how to look at data. You can also define data charts. I'll show you that real quickly. But here I have a control, or I'm sorry, I have what's called a monitor. This is monitoring my radiant controls. And I want to see the temperature in I have 2 buffer tanks for my floors, and I have 2 sensors, one at the bottom, one at the top for each tank, tank 1 and tank 2. And I'd like to be able to look and see what that looks like basically right now. So I just select what I wanted, select the thing, et cetera, and I just say generate chart.
This is my favorite part.
And there's the chart. So I've got 2 temperature sensors, the top, the bottom. The red is the bottom, the green is the top. And you can see the top is always going to be pretty much higher than the bottom. And these swings, probably happen at the time that everything is idle. So the bottom temperature starts to drop as the heat from the bottom rises to the top. So you can see in here at you can see in here, whatever this time is, that that temperature is 114 degrees, and this temperature is 115. So that was 114 at this lowest point. And so, you can get a pretty good idea here of what's going on. So that's one thing. If you want to go out to Excel, I'm going to try something I didn't try earlier. Let's see what this looks like. Right now, what it's doing is the system, ENV, is sending that data up to my computer and shoving it into a spreadsheet. I'm not sure why this is taking so long. It doesn't normally. And there's all that data.
So those are the real-time point temperatures that you could then graph with Excel if you wanted to.
Absolutely. You're in the native Excel. You can do anything you want with this. And of course, if you wanted, I'm going to close this down again. If you wanted, you could go back in time. Let's go back to January 1st. I should have done it like this. January 1st. I'm going to look at the January 1st data. And that's what things look like January 1st. Or I can go from January 1st to January 5th. Now, this is going to look scrunched up on the chart because I'm going through so many days.
Yeah, you got 4 days worth of data on there.
Yeah, exactly. So that's going to be rough. But if I go out to Excel, I hope you get the point. This is going to take a long time to get.
You can chop it into smaller bite sizes.
Yeah. Yeah, actually, it came up a lot faster. So you see I'm running from January 1st, 2nd, 3rd, 4th, and 5th, et cetera. So, again, I hope you have the idea. And when you're creating a spreadsheet, you can select all of these. When you're charting, you can only select up to 7. And I can also start a real-time monitor. This is real nice as well. This is tracking right now, real time, in a chart format, what we're looking at. And I can increase the sample rate or increase it in this case. And so, I'm actually watching this temperature change. Now, it's not changing very fast on this particular application. I can look at it in columns. I can look at it in a bar. I can go back. I can go back to here and look at these. Now I'm looking at digital outputs. They look a lot nicer in a bar format.
It's either up or down, right? It's on or off.
Yeah, exactly. On or off. I guess they're all off right now. Yeah, so if one of these came on, all of a sudden you see a bar jump out. Yeah, and these are my 3 heat pumps, by the way, that are heating my buffer tanks, and they're prioritized. So this is kind of cool. I didn't talk about this before, but this is really cool. When you set up a virtual control device to manage these 3 heat pumps to heat a buffer tank, you can set those things up in one of 3 ways. You can say, I want to go in sequence. I always want to start with 2, then go to 3, then go to 4. And when they shut down, I want to go back to 2, 3, and 4. Or you can go into rotation. So if 2 starts and then goes off, the next thing that will happen is 3 will come on. And if that goes off, then 4, etc. What I like and what most people do is maximizing not maximizing runtime, but balancing runtime. So if you have this heat pump, maybe it's a more powerful heat pump, whatever, and it runs for 3 hours over the last 4 hours, whatever, then the next time we look, we're going to bring on the one that's run the least amount of time. Now, that's how we start them up. The next thing that we do is, well, when do you bring on the next heat pump? How do you know to bring it on? So again, we're looking at delta T's, and we're saying, the delta T is tracking upward. There's no need to bring on another heat pump, because we're doing fine. This one heat pump is handling it. Or that delta T, and we're looking at what's called the least squares math calculation, which gives us a slope. We're looking at the slope, and we're saying the slope is going up, great, or the slope is going down, problem. Now, when you set that up, you can say, look, I want you to monitor that slope for a minimum of 10 minutes before you make a decision, because that slope may be bouncing around. And so once you go by that 10 minutes, then I want you to start sampling and look at the sample for about 1 minute, and then you can make your decision. So those are all parameters in the system, and you can tune them to deal, with the best situation. I got one customer that really knows this system, and I kind of explained all this to him, and he has 2 heat pumps with two stages in each heat pump, and he was getting overcycling. That's what the mechanical contractor left him with. So he got in there to that control, and he started manipulating those sample rates and the sample time. And he was able to he called me and he said, this stuff is running great now. I am not overcycling. I'm keeping the whole house comfortable. It's working great. So again, no custom programming to make all that work.
We have a fresh question.
Yep.
Rich wants to know if there's any built-in self-diagnostics or bad sensor detections, etc.
Well, again, yes. I hope I can answer his question. So you have these things called conditional procedures. And in these conditional procedures, I alluded to them earlier without getting into the detail. I'm getting you now into the detail. So these conditional procedures are used, let's see. I was looking for one that I'd set up. Anyway, a conditional procedure basically has a name. Everything in our system you name. You can name them anything you want. This particular conditional procedure, this is the test you want to make. And you drag and drop these values in here from this keypad. So let me show you how you would set up a condition. Oh, what did I do? I'm sorry. I can do it from here, I think. Okay, let me add a conditional procedure. I'm going to call it Mark. And I'm going to lock it so the customer can't touch it unless he has the proper passwords. Now, what do I want to do? I want to see if this digital input, which is, I have none in my house, if this digital output called the recirculation pump, so it puts it in there for me. And this is a digital out, so it's either going to be true or false. If that equals true, I'm sorry, let me change that. If that equals false for 60 seconds, then I want to alert the customer and the service organization, and I want to execute this macro. I'm making things up here for you, but I just want to show you how easy it is to set up a condition. So I don't know what condition you wanted, but it's just described in here. And so when I add this, then I'm going to start monitoring this pump. And if it stays false for 60 seconds, I'm going to get an alert on my cell phone, as it turns out. Did that answer the question, Mark?
I think it does. Basically, you're going to have to put those parameters in, and if a sensor goes open, then it's going to look extremely cold, and it would send out a conditional procedure alert.
Right. Now, these can be more complex. So that and this analog input, which is a bottom tank temperature, is less than 40. So now this is the condition. The pump has been off, the tank temperature is less than 40, and it's doing that for 60 seconds. I want to know about it. And by the way, these can be just informational, which means you'll get it one time and that's it. Or it can be a warning, which you'll get it on 2 successive days, or it can be an error. And if it's an error condition, you're going to get it every day until you correct the condition. If you correct the condition, it will automatically clear out this error situation, and you won't get it anymore.
Very interesting.
Yeah, let's look at, here's the dew point calculator. Where is that baby? Right, here's the dew point calculator. And now it's expecting a humidity sensor. Let's see if I have one in here. I used to have one. Hold on. The dew point calculator is expecting humidity and temperature. So here's the humidity sensor. And here's the sensor, temperature sensor. So if the dew point, based on this humidity and this temperature, +2 is greater than this temperature, then let me know. Or turn off the cooling cycle, or shut down a zone. Remember, these are just macros down here that can do anything you want. Let's go quickly create a macro. Would you like to see that?
Sure, I've got a lot of macros in my house.
Okay. So let's see if I can get this working. So I want to have a macro called Mark. Mark forever. I can't type, sorry about that. And when Mark executes this macro, what he would like to do is to turn on the living room. He wants to turn the living room off. He also wants to execute he wants to enable the domestic hot water, and he wants to disable that mixing valve, and he wants to change the set point on this recirculation point to 60. There you go. Now, if you're back here in the dashboard and Mark clicks here, all those things will happen. Cool?
That is cool. One button.
One button. And these are all the things it does if you click on that question mark, if you kind of forget. So here's vacation mode. No, I didn't want to execute it. I just wanted to see what it looks like. So the way I set up vacation mode, I set this up for you guys so you can kind of see how the thing works. But in this, if I click here, it would turn all of my zones off.
Off or down?
Well, this particular thing says off. I can go into here
and adjust it to, like, say, 50 degrees or whatever you want for a set point while you're gone.
Yeah. So where was that? Vacation mode. I can delete that row. And now what I really want to do is turn my heat set point to 57 degrees. And now I want to go into, but I did them all, but I really want just the kitchen radiant to go to a cool set point of 63 degrees. So you just keep adding the rules and you save it.
Limited only by your imagination.
Yep. So now if I look at vacation mode, it's more complicated. Okay?
All right. Well, let me ask
that's easy.
Our attendees, if anybody would like me to enable their microphone, say yes in the Q&A box, and I'll turn your mic on so that you can talk to our guest directly and answer any questions that you may have. No one has any questions? Guess you did too good of a job, Ron.
I don't know. It could have been so bad nobody understood.
Rich commented, and this is rare for Rich, believe me. It says, one of the few occasions where I will refrain. Well, thank you for refraining, Rich, but I'm not afraid. I can turn you on.
Oh, can I show real quickly, show the visualizer?
Yeah.
Okay, I forgot if we have enough time for that, Mark.
Yeah, we're fine.
Okay, here's the visualizer. Again, this is my home. I can show you some really beautiful ones that some of our resellers have created. This is my mechanical plant. Here's my 3 heat pumps that heat my buffer tanks, which heat the radiant floors. I did all this through the visualizer. I had no background, predefined background. And so let me start the visualizer. Now it's starting to run. And it looks like nothing is really happening right now. So let me bump up a set point on lower level radiant. So I'm getting ready through this virtual thermostat to turn up the set point on this lower level. Now, right away, you can see that this indicates that guy's on. I also know it's on because I see the rotating thing. I'm starting to see water rotating. This is what's the term, Mark, where you have
primary, secondary.
Yeah, primary, secondary. These are primary, secondary. These are the temperatures that I'm measuring actually on the pipe. Supply 112. There's a mixing valve here that I'm not showing that is operating off of a reset schedule. which is operating off the forecast. And this is a return temperature coming back. And this is the pump, that's driving the primary. Then it has separate zone pumps for each of these zones. They chose to do that rather than zone valves. This is the domestic hot water loop. And I need to go back to the browser. Right now I have the electrical circuits. This is normally heated by this heat pump. I think that's right, this heat pump. And here are the two buffer tanks. At the top, I'm running 140 degrees. That's because I have the electrical circuits on as well. And the bottom is 122. I'm running an average between these two. That's my current that I'm, managing to. Let me go back to my browser to my control devices. This is the control device for my domestic hot water. Right now, it's at an average of 132. I'm going to bump up that set point to 135, and I should be able to go back in here and see this thing running. Because, my set point's up. Now, I want to disable my domestic hot water. So you can access your macros right here. And that turned off the domestic hot water. That simple thing. And you can paste on any macro you want, any or all. You can also link. Let me put this back on so that my wife doesn't yell at me. So that guy's running. Let me set my set point back down to what we normally run at. We run about 118. My heat pumps, that's about as high as they can go and be efficient.
There's some new heat pumps out. We actually had Water Furnace International as our guest back in, I believe, December. They have a hot gas bypass now on their compressors that will kick 140-degree water temperatures up.
Wow, that's cool. By the way, this is my recirculation control device. I mentioned to you I'm running that at 103 degrees. In other words, if you go to any faucet in this house, you're going to get 103 degrees. If I want that higher, hey, no problem. No problem. I now want to recirculate it at 114. It's done. That's all there was to it. I don't have to go down in my mechanical room and rotate a mechanical valve. That's it. Total integration.
Cool.
All right, what am I missing? I'm missing something. Oh, I wanted to show you how you can link from one drawing to another drawing. I didn't mean to do that. Okay, so here's another form of my mechanical room. This was for demo purposes. I want to look at my bedrooms. I can set up hyperlinks to other drawings. And this was just taken off of a mechanical drawing. And these are different zones. And we just simply pasted these on using the visualizer to do that. So, you kind of recognize these from that other screen. Now I want to go back to this. So again, you can jump around. I mean, you can do some, whatever you want to do here. You see, this is that kitchen zone that's running right now. You see the kitchen is on, but the living room is off. These three zones are off. If I set these set points up, that guy turned on.
Cool.
Okay, I think I've talked myself out.
Well, I don't see any other questions, so I think I'm going to take back control and get us out of here so that everybody can go back to doing whatever it was before they came here and eat dinner. These things never work the way they're supposed to when they're supposed to, do they? Wrap this up real quick. just by thanking you first for your time and information. As always, it's amazing the stuff that you have that these controls can do, and I would encourage anybody that has an interest in possibly talking to Ron to contact him. Ron, you want to give your URL and your number for work and have people call you?
Well, sure. If they go to climateautomationsystems.com, that's plural, climate.com, you'll see that presentation and go to the contact tab and key whatever you want, and that'll come to me. Otherwise, you can come to me directly through Ron, R-O-N, at climateautomationsystems.com. That'll get to me as well, either way.
Great. Well, again, thank you very much for your time, and thank you to our participants for having come in and spent the time to listen and educate themselves on what's available on the market. And we look forward to seeing you folks next month when we will have Al Wallace in. Al is an interesting person. He's actually a hydronic ground source heat pump contractor, sits on our technical committee for IAPMO, and has actually helped develop the Uniform Solar Energy Hydronics Code. Al has a very unique system that he's actually applied for a patent on that is a compressorless cooling system. So if he's got a vertical borehole, he can extract the cool out of that hole and put it into his radiant floors and provide that as a first stage of cooling. And be a very interesting conversation with Al. I've known Al for about 15 years. So without further ado, I'd like to thank everybody. Adam Hill has a note here. He says, no question, but it's very impressive, and I really appreciate your time. Thank you very much, Ron. So the participants are thanking you as well as me.
Okay, and I really appreciate all the time you guys have spent with us. It's something that I think I love. It's been a work for me for the last 4 or 5 years, and we've enjoyed doing it. And so if you want to contact me, please do. I can talk to you about, pricing, et cetera, and I can also give you a more extensive demo if you'd like to do that. So, but again, bottom line, thank you for staying with us.
You bet. Thank you. And we'll talk to you all next month.
Thank you, Mark.
You bet. Take care.